about ready to get started, so everybody can get seated. I love the crowd. I mean, there's a lot of people here. I'm glad there's interest in this topic. I think we have a lot of great information to share. There's a few slides I need to go over, just some housekeeping that we typically do. But today we're talking about VDC and prefabrication, reducing waste and providing schedule assurance. So that's what we'll be talking about. Beyond. Oh, it does help if I turn this on.
Next slide.
All right, so these are all our sponsors, and I tell you what, all of these sponsors help us bring these kind of events, and I definitely appreciate you. So if your company is on this list, I thank you so much. We will continue to have great presentations and content for the membership, and it's all because of your support. If you're not on this list and you want to get on it, then we will have a slide that will talk about that. The order maybe is not the most ideal. Stay tuned. Stay tuned. We will talk about the sponsorship and how you do it. I know this seems crowded. We will fit you in.
It's all scalable.
That's right. It's all scalable. So we'll come back to that. This is a QR code. We definitely want to encourage everybody to follow our LinkedIn page. We send out a lot of notifications through that. Yes, you're probably getting notifications from LCI. That's great. But we put a lot of content out there. Like we're going to record tonight. In fact, that reminds me, I have to start the recording.
You record only.
Yeah. Yes, thank you for that.
I'm recording.
We will post the video online through our LinkedIn page on YouTube. Okay. Of course, I can't do it with this going. Sorry about that, guys.
So on the LinkedIn page that Sully was talking about, we have videos up there. You probably like Sully said, you probably get emails if you're a member of LCI or a corporate member. You get those emails that remind you there's going to be events, but the ones that we make on there are so much nicer. They actually give you a lot more content too. So.
Okay. So you can scan the QR code and basically just follow our page. This is the Plus Delta app. I put this slide in here. If you want to get on the Delta app, Plus Delta app, and you can start putting things in right away, we will have this slide at the end when we do our Plus Delta. I'll give you guys a second if anybody wants to scan that. All right, like I said, we'll come back to that. Okay, now we're going to talk about sponsorships. So sponsorships for 2026, it's $2,000 for the entire year. For that, you get basically three tickets to all of our events. And we have a lot of events this year. So there's a lot of value to anybody who's sponsoring. I'd say you're probably really close to getting your money back just from the cost of those events. Does not cover trainings though. So definitely make sure, but we have a lot of events. And then of course, we're gonna put your logo on that logo screen, and every event, every training, everything we do, you will get recognition from your peers. Slots will be limited, and this does not say when it stops. I think is it May, Tom? Do you remember? Yeah,
May 1st.
So this year we've instituted a new thing where you can get a membership up through May, and after May, we're closing memberships until the next year. So time is of the essence. If you want to get on there, talk to somebody, get that going. You can contact Juan. Email is right down there. He will set you up, send you the information on what you need to do to become a sponsor. Okay, so April 28th through 29th is Lean Design Forum. I believe this is in Chicago, yes. So that's coming up quick. So if you haven't already signed up and you're interested in going, definitely go on to the website and check that out. And then of course, the 28th Congress is in Atlanta, Georgia this year, October 12th through the 16th. So that should be a great time. If you've never been, I definitely encourage you to go. Lots of great content there as well. If you want to get certified, so if you want to have actual proof that you're a lean practitioner, you can scan that code. It will tell you the process and what you have to do to get that certification. There's a certification for construction, and there's one for design as well, depending on what your interest is. So this is a new slide, updated e-learning courses. So there's a lot of new content on the website. If you're a corporate member, this is free to you. So if you're interested, you can scan the QR code, or you can go to that website there, check out the content. There's lots of new stuff. It's always good to keep current. And if you're membership, if you're a corporate member, it's there for the taking. So leverage that. All right, training opportunities and coming events. Like I said, we have a lot of stuff planned. So, and I would say this isn't even really everything. This is the majority of what we calendared. Potentially there'll be others, but you can see we have more than one event on a lot of months. There's several trainings planned. On Friday, there's the last planner training that's already sold out. We will have another one. It's not on the list. We'll have another one here in Sacramento later in the year. If you're interested in that, eventually we'll put it on the calendar and that will be up there. There's a CBA workshop that we're going to do. That's a whole day event. Like if you really want to learn about CBAs.
2 days. We're going to be doing
2 days.
one
Okay.
here. And
Well,
one
2 days. Yeah. 2 different
Yeah.
locations.
So DPR.
One in Sac, one in Sacramento.
Exactly. One Sac and one.
And then we do want to do the high performance leadership training later in the year, and then another intro to lead. And then we have a few webinars there too. So a lot of events, a lot of good stuff. All right. So now it comes to our feature presentation. Everything you've been waiting for. Okay. This is actually the second part. We did a presentation back in October, and a lot of the consensus was everybody wanted more information. We covered a lot of different topics in that presentation. So this is a part 2. We're drilling into prefabrication and how that works with VDC and how all that kind of ties into lean. So prefabrication, reducing waste, and providing schedule assurance. So this is kind of a little bit different than a normal panel discussion. We are actually going to present on 3 case studies and talk about the strategies that we used and the lessons learned that we got from those. And we'll talk about different kinds of prefabrication. There's a lot of different ways of doing this. I want to encourage everybody to ask questions while we're going through it. We will have a question and answer thing at the end. I don't feel like you got to hold your question all the way to the end. If you want to know something, just raise your hand and we'll let you, ask the question of the panelists. I want it to be interactive and we can kind of get through this. We're going to kind of make the connection, one, about why VDC is so critical to the prefabrication process, why they go hand in hand and they make that possible, and why that process actually supports lean. How does it remove waste and how does it drive outcomes? So that's kind of what we're going to do. We're going to start with our first, forgot about introductions. Okay, so I'm Sully Sullivan. I'm the vice chair of the Northern California COP, and I'm just facilitating.
I'm Joanne Brooks. I'm a senior project architect with HGA. Worked on a couple of projects where we've utilized both VDC and prefab, and I'll give us our insight before I kick it off to the case studies on how everything's being used.
All right.
Joe Souza, APM with McCarthy on the hospital project I'm going to be talking about. I was the manager for the prefabrication and also managing the interiors.
Yeah, Kent Ridgely, VP of.
They had our names listed.
Yeah,
Oh, sorry about that. I still messed
No,
that up.
no, you picked on
It was a job of Sully. So, Justin Tucker, I'm the Director of Pre-Construction for M3MEP, and I oversee the VDC team.
I am Kent Ridgely, Vice President with M3C, and we'll be talking about our experience on a 3-story MOB.
Awesome.
Travis Carter with DPR. I'm going to talk about our pre-construction strategy on the 48X complex right down the road.
Which is right down the street. Everybody's gonna drive by it when they leave tonight. So that's all of our panelists. All right, now we're going to get into the very first case study, Joe.
Oh.
Oh, I'm sorry.
It's okay. I'm gonna stand up because I get nervous, so it'll help me move around. So as the architect, when we're doing VDC, one of the things that I always say is tell your architect that this is what you want to do from day one. And the other thing is that I was talking to some of my other architects that I was prepping for this meeting. And honestly, prefabs isn't a surprise to any of us. We've been hearing about it for a good solid decade. And so now it's finally gonna happen. So now we're like, oh, it's finally happening. And so for us, it's like, okay, we've been thinking about like, what do we think, what should be prefab? We all have we've been thinking about this for a while, you know. Right now I have a project, our company has a project where we have apartments. And sometimes the bathrooms are completely prefab, sometimes the kitchens are prefab. Most of these case studies today are gonna be about healthcare. So we're gonna talk about head walls, we're gonna talk about, again, toilet rooms, things that are easily repeatable that you see throughout projects. But we wanna participate in this. We've been hearing about this for a long time. This isn't gonna be a shock to anybody. So come tell us and we promise we won't panic. Or we might for a hot minute, but we really do think that this is the way of the future. We do think that this is the way technology's headed. So it's a great way to, you know, increase schedules, makes our clients happier, sees us working as a team with our contractors. It feels it helps get rid of that, you know, push-pull that always goes on between contractors and architects. I think it helps drive everybody towards a common goal. So, and remember also that we have to do a fair amount of planning early on. So we might end up spending more time on this at the start of the project, like figuring out what is our BIM execution plan? How are we putting the drawings together? How do we model things ahead of time? So that way when we're going from LOD 200 to 300 to 400, so that way it becomes an easy handoff through that Revit model. And you'll see how those handoffs occur from these guys. So I'm gonna hand it over to Joe and he'll start it off.
Before we hit Joe, I think you're underselling it a little bit, and that it's critical that the design team and the architect is on board.
Yeah.
Because you have to design the building with prefab in mind. Yes. Okay, Joe.
All right. So a little bit of a brief project overview. So this is a large hospital tower in Roseville, 6 stories, 270,000 square feet, 138 new patient rooms, 38 ED treatment rooms, and then 4 ORs and 2 hybrid ORs. So basically a new hospital. So these are some of the questions that we're going to be answering here. And this is specific to trade partner prefabrication. Later in the presentation, we're going to talk about industrialized construction and kind of compare and contrast the two.
Thanks, Ron.
Yep. All right, so I'm going to come over here a little bit. So these are photos of our modular wall units that we prefab on the tower. We have the MAC units, which our plumbing trade partner coined the name. Basically, it's a modular sink, modular showers. So we had 520 of those, and that is made up of just framing and then plumbing rough in. We also had head wall and foot wall units for med-surg and ICU rooms. The head walls are made up of framing, med gas rough in, electrical rough-in, and then also we had putty pads, fire stopping on those, and then the foot walls is electrical rough-in as well as just the framing and the fire putty pads. We also had zone valve boxes made up of med gas and then fire stopping. These photos are all from our mock-up that we did early on in design. We painted all of them orange and blue so that when the architect, owner, anyone walking through the project or the mock-up, they were able to see what was prefabbed in relation to the rest of the stick-built areas. I don't have a picture, but we also did prefab family stations, which is just the area in the patient room where the family is, where you have the light switch, TV, shade controller, all in alignment there. Just trying to make it more efficient. Next slide. All right, so design considerations. Where did we start? On this project, we had a head start because our owner had done previous projects where they are into the trade partner prefabrication. So it was really pushed from the owner side, but we still had to get together with the design team, our trade partners, and figure out what can be prefabricated. On previous jobs, they prefabricated the head wall, the foot wall, and then the MAC units. We looked to figure out what else we could do, so we added the zone valve boxes, and we also added the family stations into the mix. So one of the things really important with this is the inspection and HCI sign-off. HCI was really involved in this process. We actually had them come tour our mock-up and give us feedback early on, but there was a lot of discussion around, well, how do you sign off a prefab element at a warehouse when it could go get installed and get tested and it fails a test, but we already signed it off. So we ended up getting to a point where they're observations as we are building instead of an actual sign off, but really important to have your IOR team, HCI involved early. And then VDC coordination, why we're all here. On the left, you see the model. This is of our ICU room. The shop drawing that we used to actually build it. And then on the right is the final mock-up that we did. So you can see how it translates across and how important the modeling aspect of it was to get it to the final place. And then one thing that's interesting on this project is typically we do mock-ups right before construction. We did a mock-up all the way in the design phase to influence the design before our drawings even went in for permit. So not only did it help advise construction, but we were able to build our drawings and get them right before they went in instead of having them NMAs and ACDs to change a bunch of items. Next slide, Slick. So through that design stage mock-up, we were able to have some improvements with the head walls mostly. And this was really brought on by our owner, who was really pushing for continuous improvements and what more can we prefabricate. So a couple of them here. This is our med-surg head wall and the template plate that's used at the back. We were able to extend it to help with, instead of having rows of backing for the phenolic panel to attach, it's a full overall backing plate, basically. On previous projects, they had just a smaller backing plate that just locked in where the med gas and electrical outlets were. You'll see in the next slide, the devices, we were able to mount them behind the template. One of the issues that they had on previous projects was drywall buildup from items getting mounted outside of the template that then pushed the phenolic panel out, and there was a bunch of shimming. So that was one of the things we really wanted to highlight. You can see here, this was a previous configuration and what the outlet looked like and how it's pushed off a 1/4 inch of the wall in some places. So then the drywall would bulge and that would lead to other issues. And the new configuration where we worked with Beacon Medeas to get a different outlet to put it behind, as well as getting the mud rings for the electrical boxes behind. So you have a pretty smooth surface there where you're not going to have those drywall bulges. The other big improvement was at the previous projects, this extension piece was the exact size of our overall wall assembly. And so you'd have this concave situation where the drywall is pushing everything out, but this is very limited. So where the med gas outlets are, it's pushing the panel in. We worked with the manufacturer Beacon Videus and was able to change it from 3.5 to 4 inch. So we have a little bit of flexibility there and fix that issue. So moving into construction, with trade partner prefab, there's a lot that needs to be considered. It's typically we have, our job site trailers and then obviously the job site. But for prefab, we got to figure out where we're going to do this prefab. So procuring a warehouse, figuring out, working with the trade partners for how much you're going to prefab, what you're going to prefab, how much space you're going to need. You can see in the middle here is kind of our overall warehouse layout where we have the framers, the plumbers, electricians, and how the panels would move through that. We have to obviously figure out location as well. How far is it away from the job site? A lot of logistical pieces there. Schedule, getting with the trade partners early to make sure that everything that you're going to be building off-site is going to work with the construction schedule and what the sequencing looks like. We definitely had our challenges in the beginning there, and we were able to save 2 months off of the prefab getting it done this way. But just early involvement with the trade partners, how many units they can do a day of each unit, what the sequence is going to be. You obviously want to have you want to be doing the same unit at once, so it's a repetitive task instead of swapping floors or areas. So all things to consider there. And then what the QC unit tracking actually looks like. We ended up, this is an example of the dashboard that we showed at the CA meetings each week that had the % complete. We used Smartsheet to track it along with barcodes, where our trade partner, once they were done with the unit, they would scan a barcode. It would basically say unit done with electrical rough-in or done with plumbing, and then it would update to this back spreadsheet, and we'd be able to present of what the % of each one complete in the warehouse was. And then the transportation is at the end, you put all this effort into actually building it, but if it doesn't make it to the job site safe, it's for nothing. So really worked through that with our drywall and framing trade partner. Their custom pallets, you can see on the right for all the different sizes of units that we're doing, as well as they're basically bubble wrapped. I mean, they didn't get hurt on the way, which is great, but they're on dunnage, they're wrapped, they have labels of exactly what's on what pallet. So all things to consider when setting it up. Next slide. So here's some photos of the warehouse, and just want to talk about the advantages of prefab. One obvious one, it's a controlled environment. You aren't dealing with the weather. You aren't dealing with moving to different floors to getting things done. You're working in the same place every single day. It's repetitive, which makes it more efficient. You can see, so on the left here is the rotisseries. These are head walls and foot walls that were put on these rotisseries and kind of passed around the warehouse to each of the trades, which leads to the safety aspect of it too. Instead of having to get down on your knees for a rough-in or get up on ladders, whatever it is, you're working on something that's waist high the whole time. You have Mac units that were just sitting on tables that you're working on. So real good things there. And then the quality, the middle photo is of our first units that we made. We had them at the front of the warehouse. We brought the architect, inspection team, owner, everyone through, made sure we set the standard of quality before we started. So we just kept referring to those. But in a warehouse, obviously, you're able to control the quality a lot better than you're able to in the field. The process had some challenges, though. Want to highlight a couple of them. We had areas where a trade partner would update the shop drawings and it wouldn't make it to the whole team. So then there were some panels that were built wrong. Maybe the width or a pipe was out of place. We found it in the warehouse. We're able to correct it again before it goes on in the site. It's roughed in. So that's a big win at the end of the day. It just had a little bit of a setback. Trade partner production, just making sure that the schedule and what each trade partner can produce each day, whether it's 4 units, 3 units, that you're not having a situation where one trade partner has more guys and they're standing around because another trade partner like plumbing was only producing 3 units and they could actually get 5 units done a day. So making sure that was balanced. We had some moments where we had to change the crew sizes to make sure it worked out. And then the special inspections, we had HCI, we had the IOR team involved all through our mock-up, through the design. But when it came to actually doing inspections, the observations, there was some questions about, well, what structural drawings, what plumbing drawings? We can't inspect off of shop drawings because we would show them that shop drawing and they said no. So we had to make some updates to our drawings to make sure that it was inspectable. And then the unit tracking, there's a lot of discussion in the beginning about, do we use unique identifiers for each unit that we're tracking, or because you have a bunch of head walls per se that could go in whatever room. Do we want to pigeonhole ourselves into, if one's at the bottom of the pile, can we get it into the room it actually needs to go into? And we did that for everything except for the Mac units, and it worked out great. And funny enough, when the Mac units were getting installed, there was a little bit of confusion and issues with, they didn't have the specific ones going to specific areas. So when we had challenges, they couldn't figure out exactly how many they had or which one were the issues. And they had a big lesson learned that they're going to take forward onto their next project, that they're going to go to unique identifiers. Next slide.
Quick question. So on the backing plate, what did you guys have as far as the tolerance between the backing plate and the phenolic?
Not much. We were looking at that med gas outlet, that's the 3.5. That's exactly what the assembly was. So it was, I would say 8.25. It's on the previous projects, if you take off these phenolic panels, there's a bunch of shims underneath to make sure it's all flush. And that was one thing that we were really trying to reduce.
Yeah, one thing I'll say too is that backing plate served to lock in all the devices.
Mm-hmm.
And since we had to match up a phenolic panel, we used the same template to cut the phenolic panel as we did that plate. And when we did the mock-up, they married up great. Like, there were no issues. Everything went on. Everything lined up exactly. Because that was a concern, right? Like trying to have 2 things. But that backing plate really was key in making sure that everything was consistent.
Yeah, so what were the outcomes of this trade partner prefab?
I have a question.
Oh, sorry about that.
Were you fabbing the CFS in the warehouse, those little boxes, or were those prefab and getting shipped on site?
CFS.
The cold form steel, like the thing that you put all of the weapons in.
Got you. That's the template plate you're saying?
No, you're
No,
framing at the template.
Framing was all
Oh,
framed by the
yes, sorry.
framing contractor.
Yes,
In-
framing
In the
contract.
Correct, part of the
warehouse.
process of assembly
It wasn't prefab.
was
like
not
No,
prefab
so-
offsite.
Yeah, to speak to that, I couldn't find a great picture of it, but they had basically framing templates or fixtures that were on wheels that they would just put the studs in and just have the exact dimensions that they needed. They basically went into the warehouse and just knocked out the framing, and we had that stacked up high, and then it was from plumbing and electrical that caught us, basically.
But I mean, it's technically prefab, right? Because it's offsite. It's just not bought from a shop or something like that.
I'm with you.
Real quick, sorry.
No, you're fine.
Were any of your systems full height? And I mean, from deck to like ceiling or to bottom of steel or bottom of pan decking or what have you?
No, they were.
Yeah, so we purposely got it a certain distance above the ceiling so everything could come out. But we did not go to the top just because of the challenges of trying to make something full height and all of the inconsistency that could happen. That's also why we did the curb, because we wanted to be able to control. We actually learned from a previous project that they had a lot of problems with uneven slab surfaces when they tried to do their prefab modulars. So our fix was we put a curve in, we get it to a set datum so that it could just set into place. And it actually worked really well.
Yeah.
A little extra work, but set us up for success.
I have one. So for your prefab full height walls, priority walls, do you guys let the fire sprinkler trade go in first, or were the full height walls in first?
Prefab. Oh, you're saying just our priority walls?
Yeah, the full height. Do you guys let the sprinkler guys in first?
Yeah, I think we did let them go in first. But that presents its own challenges as well.
Whole other event.
Yeah, priority walls is another
Little bit outside the scope.
could be another hour-long.
Great questions. I want to encourage that more. Did you want to hit on this last slide?
Yeah, just the last slide, the outcome. So because of the design mockup, because of prefab, our trade partners were able to save about $2 million due to the efficiencies. And then schedule, we were able to, like I said, we were able to have the prefab completed 2 months ahead of what we scheduled with the trade partners, making sure that it was ready to go to the tower when necessary. And then another benefit of prefab is when you can't work on site, you can get this all done beforehand. And the goal is to have the same people that do the prefab go install it, since they're the most intimate with it, which we were able to do in a lot of cases. So that was great. And then this is a picture of our first in place ICU room in the tower. I should have just highlighted it, but so this sink has that prefab MAC unit. This is obviously the head wall. That's all prefab behind there. The family station is prefab. And then you have the lavatory that's prefab as well. Not photographed, but the football is on the opposite side. So, yeah. And now I'll question?
Yeah, real quick, how heavy were these panels, and did you just tilt them up by hand, or did you have to have some type of
They
device?
use, there was some discussion about that. What's funny is the manager for our framing trade partner always had in mind that they would use a jack to get them up, and then when it got passed off to the superintendent, he was like, no, put them up by hand. And after a lot of conversation, they ended up using a jack to get them in place, which we actually had lesson learned coordination. We had some hangers that were right outside of our elevation. Like Sully said, we had the conduits and everything coming out right there. So when they went to jack them up, they were right in line with where they were going to be. So we had to undo them, put it in there. Another lesson learned.
Yeah, well, one thing that we did too is that on this head wall, it's actually 2 panels, a left and a right, and we left a gap in the middle. to make it easier to put them into place. And it also made it lighter. I mean, it's not to use a jack, but
Yeah.
if it had been one piece, it would have been twice as heavy. And you would have had to try to get it into that framed in opening. So it would have made it harder to get that precise.
Yep.
Any other questions?
Second question on the inspection, is that, or the observations, was that a special inspector? And was he or she on site all the time? Like, could you achieve single piece flow, or did you have to batch? They come in, inspect a certain scope, and then
Yeah, so great question. So we had a special inspector, 6020 for MedGas that was there all the time. He was able to do a lot of the other inspections as well. We had our lead IOR come out as well. Another lesson learned on that with the zone valve box is we fire caulked the penetrations coming out of the box, and they never went through special inspection. Even though we had a conversation with the IR team about this, there was a miscommunication. So when they were getting ready to come on site, there was that question, and one of our lessons learned is let's just wait to do the fire stopping on site.
they do.
There's not a lot
So
of
that, by the way.
So one quick thing I want to point out, the $2 million savings. So when we told the client that we were going to do all this mock-up early on, we got a lot of pushback.
Yeah.
And they said, well, we don't want to pay for this. You're going to spend all this money with stuff you're going to throw away. We went through the effort of proving that we would more than pay for all that work and have savings on top of it. And then they were sold. And I will say, once they saw the warehouse, they were having tours of that all the time. So they actually really liked it, but there was a lot of pushback in the end.
What is that 2 million savings based on? Like percentage, $2 million is obviously a lot of money, but 2 million on $1 billion is not as much as 2 million on $3 million.
Yeah, I hear what you're saying. A lot of it came from our plumbing trade partner because they also did prefabricated racks, prefabricated underground. In that picture that I showed, they were the green. They had about 30,000 square feet of the 85,000 square foot warehouse. So the 2 million was 3x what was spent on the mock-up. And that savings was all figured into the target budget very early on in the process.
What was the overall project budget?
Yeah, just to get a kind of a sense.
He's trying to get a sense of what.
It's a
hear
pretty
you.
small amount.
Or combine your framing and
in
MEP stuff.
So,
Yeah, there's multiple.
No, it's
factors.
saving, and I think that's the big discussion here, right?
Yeah.
If we can have better quality, we can have better schedule assurance, like there's cost associated with that. I mean, I've dealt with a lot of discussions of prefab, and sometimes it doesn't pencil. And this is a project where you have a framing contractor that's actually on board.
Yeah.
I don't know how many framing contractors are in here, but a lot of them aren't on board.
Correct.
And that's usually the big stumbling block in getting the prefab
Yeah.
opportunities to come in. So, yeah, I mean,
Yeah, I agree.
Okay, one more question, and then we're gonna need to move on.
Did you have back-to-back head wall instances? Did you
Back to back.
Yes.
Yeah, we did have.
We
back-to-back.
did you encounter any issues with those big, massive sheet metals and final inspections on the head walls?
No, I mean, that was a testament to VDC, making sure we had the air gap, that none of the boxes were gonna be hitting, with the electrical back boxes, and gas back boxes.
Yeah, we hit a double wall with a gap in between.
Mm-hmm.
I mean, the plate kind of blocked it out, so it was critical that everything was ready to go and installed, but everything came out from it, so you didn't have to work behind it at all. So everything was already
I
connected.
have one question.
Okay, one more question.
All the color coding, I thought that was awesome. How did you know at the end per discipline on the inspections that that coordination taking it all the way to the end? Was that a visual, or how did you know all the BIOPs were in place?
We knew all the biopsies were in place from the tracking spreadsheet as well. So we did the tracking spreadsheet to show the client and everyone in the meeting, but we also spray painted the units, each unit, and then when the IOR would come look at it, he would have a different color and his signature on there. So when we knew that they were coming out, they'd already been observed, inspected.
Okay, well, we need to keep moving forward, so.
Let's talk about VDC.
Yeah.
So
I'm gonna,
we did a lot of coordination early on to make this happen. We pushed up the coordination on these because it was done early on. And in our continual learning process, we found that our tolerances weren't great enough. There would be small inconsistencies when they installed. So we learned from that process and realized we got to spread stuff out. We had a very small area to fit all of this infrastructure in. It was very, very challenging to get everything to actually fit.
Right, and so you were talking about the back-to-back head walls. That's one of the things that VDC really does lend to, is about you understand exactly where every pipe comes up.
Yeah.
Where's every box? Where's every plate? What's the actual depth of those things? It really shows up in the model. And as you're talking about them, you can make sure that you have those gaps that are required.
all right.
All right,
Hand it off to Kent, talk about industrialized construction.
all right, awesome.
All right. How many designers do we have in here? Raise your hand. How many of you have been designed for manufacture and field install? Put your hand up. All right, well, let's get to it. So for us, really, I mean, it's really looking at that early design involvement. Like everybody's talked about, where the true value of prefabrication comes, whether it's an offsite activity or if it's a manufacturing environment like ours, is really ensuring that the design criteria, that your expectations and all of that early involvement and the buy-in of both the owner, the GC, and the designer. Everybody has to buy into that and believe in it, or you're going to have wasted effort, rework, remodeling, and that's not cheap and it takes a lot of time. So for us, we really look at making sure that design with the prefab and the IC in mind. And IC is the industrialized construction. That runs the gamut of anything from a hangar all the way down to a module, which is a multitude of rooms put together, and we'll kind of dig into that a little bit later. Really, once setting those expectations and the standards in a manufacturing environment, you have an 1/8 inch of variance. That's all you get. You don't get a 1/4 inch, you'll get a 1/2 inch, you'll get 5/8 of deflection. It's an 1/8 of an inch. That's the design intent you're shooting for. So that's really where that digital model comes in to really make sure that you efficiently review that design. You look at where your critical stud placements are, how it correlates to your structural steel. Then you set your MEP, you run through all of that. Then you infill your studs. And really, you build that project digitally to ensure that you have it 100% right. It takes a lot of time, and it also there's a lot of expense associated with that. But it reduces the rework, it reduces remanufacturing, and therefore, in the end, it ends up saving us. That's the bet that we're making, is that it's going to save us in the overall project expenditure. So, really clearly defining those criteria. Looking at the design efficiencies, what do we have in repetitive items? How many walls are repeated? How many in-wall assemblies? How many cartridges? Is the overhead rack system repeatable? It can become a product. If it does, can you create a Revit family so that you can use that to spatially arrange that project in a rapid fashion so that you're not remodeling and that you're not duplicating that process either through rooms or through buildings or floors? And then really, ultimately, the holy grail would be if you had a computational design, which really for us, something that we're working towards is having a gaming engine driven AI overviewed system that allows you to have a parametric design, expand, move rooms around. It has a cost loaded structure that tells you what's your schedule effect, what's your cost effect, and what's your bill of material effect. So that you can immediately say, look, moving this boom arm and this OR costs $73,000. Oh, I think I'd be okay with it right here, and I can do it for 20. And so really having those clinicians come through in a virtual environment, changing those, because we all know when the clinicians come through, big changes affect us. It causes delays in the field and it increases costs. So the more that we can do digitally and get worked out, the better. And then really it's understanding and getting the team to buy in that when the model locks, it's locked, like it's done. Obviously, there's going to be things that occur. A piece of equipment wasn't modeled right, or it didn't sit right. And there's minor, you can't avoid those. It occurs. And that's just typical in a construction, but really knowing that when the model locks, the model's locked. And then that allows you to go into production earlier. Next slide.
So before we go on to the next slide, industrialized construction is kind of a new buzzword. Can you explain what the difference between that and?
Yeah, so I mean, we'll go through those slides and get into the details of it. But really, the first iteration of the lean process of manufacturing and industrialized construction was just moving the construction somewhere else on site. That's really, whether it's in a tent and in cargo bins, wherever it may be, hey, that shit works pretty good.
So manufacturing mindset, right?
Yeah, it's that manufacturing mindset. You're trying to implement those processes that you see in a repeatable environment, and then the next phase is we move it to a warehouse and multiple trades touch it and it passes between gates of plumbing, electrical, and it all gets assembled and built. The final, holy grail of industrialized construction is a single flow manufacturing environment where you have as much automation to create consistency, schedule certainty, cost certainty, quality certainty, and you have no variance in your production.
Awesome, great.
Yeah, so on the virtual side, whenever we're doing a design build, a design assist project, we want to get involved as early as possible with the engineering team and the architects. So when we're working through these things, it's that fine line, right? It's figuring out where we want to get involved, where we're not running into a ton of rework, where we're not going in and trying to model things to the point where we got things like hangers in, or we got to move 1,000 hangers because we wanted to go in and populate those and try to coordinate those early on. So it's really using the tools that the VDC teams have and the experience on the construction side as opposed to the design side to make sure that we are coordinating early and often, but that we're also not going over the top as well. So through the construction, through VDC, we're able to prefab with I'm gonna say without risk, minimal risk, right? So when I was in the field and years of laying out sheet metal and ductwork, I would prefab spools on site as a foreman. I would draw up my own spools. Well, while doing that, yes, I can spool my own stuff out on site, but if you don't have buy-in from the fire protection guy, or maybe the electrician's not on site that day when you order your stuff, you go to install it and you got a problem. You got fights on the job site, you got arguments. So with VDC, what it does is it really enables us to collaborate together, getting all trade partners involved to make sure that we're coordinating, we're signing off models. I think I was in a appreciation lunch today where it was, what was the number? You said it earlier, 5,000?
15,000.
15,000 clashes we put on the project. So and it was over a year of coordination that we had on this job. So it takes time to get through that process. But at the end, the idea is that, the majority of the issues are brought to the table, they're resolved. And by the time we go into construction and manufacturing, we're worrying about other issues, not how we're going to build it. It's how we're going to build it more effectively. So we have here on these pictures here, this is actually one of the first projects that we've modeled and prefab the amount of electrical underground that we did on this job with the underground duct banks and the risers. And you can see like for like in the pictures here. So as we're going through this, we're constantly refining our process. Although this is one of the first projects that we've done another one since. We've made minor tweaks. So again, it's on the virtual side and the manufacturing side, we're spending our time trying to figure out how to do things better and more efficiently than just trying to figure out how to do things.
Yeah. I mean, with the labor shortage that everybody's fully aware of and feels on a pain level, it's not going to get any better. And so the more we can do in a controlled environment, the more we can do offsite, and the more assemblies and the easier the field installation becomes, the better it's going to be for all of us.
I think this is you.
All right. So industrialized construction, as we talked about, really for us, I mean, it runs the gamut, and it can be trade assemblies. It can start with plumbing assemblies, a school assembly, fire sprinkler section. It can be any of that. One of the most common, obviously, is duct. Duct has probably been spooled and pre-assembled the longest of anything in construction, multiple decades. We are in our 50th year of business this year, and I think we've been doing duct prefab for about 40 of that. So it's been a long time that's been a common occurrence. Don't know why everything else took so long, but here we are. And then even electrical kits. So much material on a job is wasted. Somebody will open a container of fittings, they'll use 2 of them, the box falls on the floor, somebody sweeps it up, it's in the garbage. That happens 100 times a day. So really one of those things you can do, and part of that VDC effort is creating what we call ship loose items. So you'll build your prefabricated assemblies, but everything you need to connect that and install that around it is what we call a ship loose. And it becomes prepackaged, it's shipped with that assembly. If you have a tack plan that's color coded or however you want it, if it's nomenclature, it'll be set in a tack plan of where those items stay so you're not moving them around the project. And that crew does not look for their materials. They don't look for those pieces. They're all like. Everything that they need is in that assembly. There's nothing to unbox. There's no parts to go find. They're not going to the bin. They just bring their tool cart and boom, they go to work. So even from there, and then you have trade racks, which can be anything from, electrical, or it could be multi-trade with plumbing, electrical, fire sprinkler, structural bracing, anything like that. It can be process piping, any of those overhead assemblies. Next one. So, and then from there you can go to EPIS panels, metal clad panels, any exterior wall panel. It could even just be a sheath. It could just be a dense glass finished wall panel. I saw some of the projects that you guys had. That was kind of the installation process you had. And then next would really be the prefabricated wall panels, your CFS panels. They can be just panels, or they can be vertically integrated with the plumbing, electrical, all of your backing, blocking, anything that's modeled will show up in that wall panel. Typically your lagger is casework. They usually like to be last, and so you got to take guesses at that. Or if you got somebody it's a repetitive design, then you know what most of your stuff has to be in the architectural process. And then from there you go to pods, whether it's an electrical room, a plumbing room, patient restroom, whatever that may be. And then a module, which may be a multitude of 2, 3, 4 rooms put into like an exam area, a module assembly of all those rooms with all of the MEP and everything else in it. So that covers industrialized construction. Next. Okay. How does prefabrication drive productivity and schedule assurance? Really for us, it allows that parallel production. If while you're going through approvals, while you're working on the site, you're doing the underground, the manufacturing facility, whether it's on site, whether it's off site, whether it's in a manufacturing facility, could be prefabricating those wall panels, those pods, those assemblies, your underground duct structure, so that you're running parallel schedules and really being able to accelerate the amount of work that can be created in a time period. With that, it allows you to compress schedules. And really, the goal obviously for the owner is to generate revenue sooner. Heads in beds generates revenue. That's what they all shoot for. And it's funny, we all know as we start a project, they always say, oh, the open date's the most important. And then about halfway through into design, well, budget's also important. And then, it's how that all works. But anyway, the part we can control really more so is that schedule through the prefabricated assemblies. And it also helps with that skilled labor shortage. Oftentimes it's easier to find people who will work in a consistent controlled environment, the same location every day, repetitively. And so it's a little easier to man those manufacturing facilities sometimes than it is a job site. And so again, shortage of labor is going to be problematic for the next few decades at least. So anything that we can do to help offset that and reduce the impact of the project is definitely a benefit. And then it also really, it eliminates the trade stacking. It eliminates the amount of equipment on site. And if you have a congested area, it can really reduce the environmental impact to the community and the other projects around you, other things like that. So there's a lot of things. You got a project that's got 15 trucks instead of 60 trucks, environmental impacts, commuting, transit, everything else. Noise, all of it, yeah. Jude.
So yeah, again, back to the electrical, so. By the way, you had this slide yesterday.
All right. So as an example of the electricals, I just figured you already running duct.
Yeah, no,
so typically for us, we were able to use a 4-man crew and install all that prefabricated duct assembly, the riser assemblies, the cages, Normally in the field, we would have an 8 to 10 person crew by a traditional stick build. So we really cut the crew, down by 60%. And then we were able to save 2 weeks off of that underground structure. And one of the things about that, and that we see a lot of times with the prefabrication, is making sure that the team buys into it, and that your resource loaded work plan, that your tact plan really pulls all those things in to take advantage of that prefabrication and the acceleration it allows, or you're wasting that time and effort. And that's really probably one of the biggest things in our early projects we experienced is a lot of superintendents, a lot of other project executives and personnel don't fully understand the acceleration possible with the prefab, and they're very hesitant to pull that schedule in tight. So sometimes in the initial phases of the prefab, there's a test period, and so there may be some pulling to that schedule. But then once you get a cadence and everybody becomes comfortable with that schedule assurance, then everything can tighten up really good.
Sometimes you end up with those old school superintendents that want to build schedules based off of.
We did have one of those. I call him a crusty analog superintendent. Really good guy. It was on a project, and he said, "Bullshit. There's no way you can frame this building or this segment, and it was 10,000 square foot blocks, and we're like, we can frame it in eight to 10 days. He's like, "Bullshit." So we put 30 days on the schedule. We went into the first one, and at 7.5, right at 8 days, we were done. He said, "Well, okay, all right." So then he started pulling the schedule in, and the project actually went really well. And he became a believer, and we ended up negotiating a second project with him. Next.
I'll take this one too. Hey, let's do it. We'll do it together. How about that?
All right. So eliminating waste through prefabrication. Obviously, everything's about just in time, whether it's material deliveries to your facility, your offsite, your onsite, whatever that means. You don't want to have a bunch of inventory that could be damaged, lost, used on other segments, or end up at somebody's house. Really, it's looking at that just in time, both for the material delivery, for the production. You don't want to be storing 45, 50 pods on site. It takes up a lot of room. You've got infectious control issues, people entering them, things like that. And so really it's looking at that TAC plan, making sure that everything is arriving just in time, it's produced just in time, and those schedules are sliding together and working very well. The manufacturing environment, really the whole idea of it is through the use of automation and controlled processes, is whether it's running your CFS studs. They're the same size, same dimension. I mean, everything turns out exactly the same every time. And with the studs as an example, typically we produce like a 4x4 bin of scrap metal from your stud cuts, your track, your backing, whatever that may be. Going to an automated process, you create a Tupperware bin about yay big out of 1,000 feet of wall panel. With that, the service holes can also be shipped as shims. So we're usually looking at about a 75 to 76% reduction in waste in compared to a stick build in that automated manufacturing environment. And that's inclusive of CNC routing your wall panels. Like they have the phenolic panels, and they have their template, for their head wall. Those things are all CNC cut, and it's automated and part of your model. And there's no error. Everything matches up each time, every time. That also helps with your inspections, because as your IOR, your HCI inspectors come in and they look at it, and your screw patterns are the same every time, everything's the same. They get very comfortable, and they just intermittently come and inspect. I think on a project we're working on right now, he comes once to twice a week at most. Obviously, if you're doing fabrication integrated structural steel, those are continuous weld inspections. The med gases, whatever those may be, you don't really get that variance on that. But through the use of an ERP system, you can digitally track any one of those components at any time from virtual design all the way through field install. And it allows those inspectors to log in at any point in time, allows the management team to log in at any time, look at where the things are in production, where their spools are, where the inspection gates are, where the documents are associated with those can be downloaded for your inspections. And then allows the field team to scan that same QR code and look at where the pieces fit within the building and how they fit in the model, so that they make sure that they're putting the right piece in the right place, and that the staging was correct, and that their first off is their first install.
And it's really about leveraging the technology and the tools that we have, and using things like the total station or Dusty Robotics to take what we've already modeled and coordinated and make sure that what's in the model is what's going to be built in the field. And then, as well as the tools that we can now give to our foremen, with the iPads, and have direct access to the models, in the field. All of that saves waste, right? It keeps them from, how many times you gotta walk across the job site to go to a set of plans because you forgot something. But having that accessibility on your iPad really helps eliminate waste on these projects.
Well said.
Got it, this one's me.
Go get it.
So, yeah. The challenges, when we're doing these kind of projects, so, like we talked about earlier, it's the design changes during the fabrication model phase. So ideally, we want to have model lock, right? We need to have that model locked from the design team as early as possible to eliminate as much rework as we can. But it doesn't always happen. So the challenge that we always run into is, when do we move forward with the fabrication model? When do we go into our LOD 400 assemblies? When do we start populating things like hangers and seismic? So that's always a challenge that we run into. Custom one-off assemblies. So with IC, with prefab, we're trying to do repetition, right? When it comes to our in-wall electrical assemblies, or our wall panels, our head walls, our bathroom pods, anything that we're trying to repeat. Anytime there's a one-off from that, it creates more waste. And so the issue with that is, you go into a design, and we say, hey, we want to standardize this exam room pod, and we want to do this 10 times in this building. And then by the time the design's done, you got maybe 2 of those, and 8 of them are built as one-offs because one of the end users wanted to change something in one room, or somebody wanted to change something in the other room. So anytime there's those one-offs, it does create challenges for us. The material procurement side, it's when do you order the material? And we're trying to stay lean. We just want to, we don't want to have inventory. We don't want to keep stock. So we want to make sure that we're releasing just-in-time deliveries and getting that material ordered. Delivery and staging of our assemblies. The more you have, the bigger assemblies you have, the harder it is to ship and stage. So that's another challenge. And then the time for the BIM coordination. That's key. Like I said, the last project was just over a year just to coordinate. So, any questions? I don't know. So, you all right?
Yeah.
Was that telling me to stop?
And I will say, again, because we've been talking largely about healthcare projects, and we have medical planners, and the medical planning takes a lot of work, but usually we try to have, whether about 100% DD or LOD 200, however you want to describe it, is about when we try to have that model locked. And we've done the major walls. We think we have I'm going to say we think, which is true. We think we have everything coordinated. And basically I joked around that after that, walls move by committee. Because I really can't move a wall without telling these guys, hey, this had to be adjusted because X, or they're telling me, hey, this has to move. So it becomes a lot more by committee. It becomes a little bit trickier for all of us to do. But then that also allows for the BIM coordination to occur, to at least start while the architecture team is going through that LOD 200 to 300 CDs level of detailing.
Yeah, if you can lock that chassis, if you want to change colors, we don't care.
Right,
But yeah, if you can lock the chassis of the building and the infrastructure, the rest of it, we don't care what wall protection you put on it. We don't care what color it is.
Exactly. And I will even say that we go back I've even gone back as far as during validation of the project, where we start setting up where can the multi-trade racks go? So can they go down this corridor? No, you can't, because there's fire ratings that we have to deal with. No, we need a ceiling height at this height. Where and really looking for the opportunities of where those multi-trade racks can be utilized.
And getting everybody involved, like the structural engineer, getting their buy-in. And I think on the project that we were looking at, we just had, the structural engineer designed our MEP racks for us to make sure that they could support the way.
So I think we have a couple of questions.
Yeah, Joanne, I really like what you just said about this walls moving by committee, because it really highlights that there's collaboration between everybody on this team right here. I know you're the resident architect over here. So you're
Right, yeah, exactly.
But one thing I'm curious about, I love the efficiency. I love what high coordination, high collaboration gets us. But the one piece that, and maybe we cover today, maybe we don't, but it's really important to me is innovation. You know, like I use this example a lot, but like you could have a roof and it could be where you have to step over ladders every 80 feet to get over all the stuff that you built up there, or you could build it very cleanly and safely and just, I call it like magic, and have it be something where it's like very usable in the future. And that really takes not only just like one designer going like, this is how I want it to be, and the rest of everybody has to make it work with their details and all that, but it really takes like real collaboration between the builders and the designers, right? So I wonder if you guys see like where you see that fitting in with this.
Well, I think especially, again, we were talking about early on in design and early collaboration. We had a project where the building really isn't designed for healthcare, and I'm looking over here at my structural engineer. Or part of my structural engineering team, and it really was not designed for healthcare.
I got one of those.
Right, yeah, exactly. And so we ended up going through a good couple weeks of figuring out how are we even going to support what we're trying to do. And they came up early on with a way to reinforce everything and an anchoring system. And we figured out how to build it. Each floor was going to be loaded differently from one floor to the next. And oh my gosh, I mean, to be doing that is in validation or in conceptual design. The medical planners are still trying to get rough in layouts of the rooms, and here we are, we're like coordinating already, our overhead rack system. How do we support everything? I mean, that was a lot of work being done very, very early in the project, and that was part of the success of the project.
Yeah, it pays dividends later.
Oh yeah, it paid them way off down the road.
I think we had another question in the back.
Yeah, I like the efficiency as a framing trade partner that has a BIM department. I'm curious as to where in this whole process, whether it's validation or in design, where does this come into play where you decide that you're gonna do industrialized construction and you're gonna have it all in one warehouse, and you're gonna have all these trade partners working together? How did that process materialize?
I feel like that was it's a very early project goal. I would say it started like almost day one in validation. That's why you have your contractor team day one. You have your engineering, you have your engineers, everybody's working together to figure out how are we gonna get this done? And how are we gonna get this done with the constraints, whether they're schedule, whether they're budget, or just really just trying to provide a better system for the client.
Yeah. I think it can be even further upstream. Sometimes it's part of the proposal process. It's your value add. You're really looking at it. You're going to this interview. You're proposing to an owner, and really to bring in an additional value. You're looking at running parallel operations to compress schedule and reduce cost. I mean, everybody wants reduction in budget, and so it's usually part of that sales process up front. And therefore, it becomes a condition of satisfaction to the customer who really needs to drive that. Because if they don't, the GCs typically don't buy in, and then the trade partners are not brought in that accommodate that. So it really needs to be all the way upstream at conception of the project and trying to procure that project.
Did we have a question over here? Anybody? All right. Let's move on.
All right. So I was going to talk about the prefabrication strategy for the 48X complex, and actually I hope to be able to answer a few of you guys' questions that came out and how we address those on this job. 48X complex, just located right down the road, corner of 48X. So the building it's an outpatient surgery center. It's got 14 ORs, has an interventional radiology department, diagnostic radiology, PACU, 2 floors of clinic space. It's virtually a hospital minus the ED, family birthing, and ICU. So it's got almost every other service. Job was a progressive design build project. And for our pre-construction, starting from where we finished, we're gonna go to the next slide. The major prefabrication elements we ended up on this job was the exterior frame and sheeting system, the interior partition walls, modular restrooms, and then the OR ceilings. Now that's not where we started. This job was a design build project, progressive design build, and actually you can flip to the next slide. We were brought in very early on this project, partnering with Smith Group, and some of these things we listed just as prerequisites to really make design build happen. Really starts with having a collaborative agreement that allows the team to come up with these ideas, come up with these strategies, and come up with the right products. So, I mean, similar to what Kent said about bringing it early on in the proposal of sales, I mean, it's really before that. And to make sure that your GC doesn't discount the idea and all this stuff is having the GC part of that process all along. For this project, once our team was developed, we actually had 2 different big room setups on this. We had a co-location site where we were housed with UC Davis Health, Smith Group, DPR, as well as our design build trade partners in a little office building about a mile north during the design development part. And then once we got to construction, we had an office actually over at the 48X complex that then ended up moving over by the mine center. It's still there. It's used by RNS right now in the Cup building, or the Cup expansion. That again, house those same people as well as our key trade partners. So at one time, I think we had up to 90 people working in that office, in literally one great big room. The value in that goes back to, especially for the VDC group, we had a VDC cluster that included everybody from the architects and engineers to the people doing the modeling, as well as key trade partner detailers. And most notably our frame and drywall detailer, because we had the interior framing system, they were providing the details for the architect because they had custom details and things that needed to get into the design. Other steps to getting where we finished. Next page. When this started out, we threw every idea we could think of as far as pre-construction on this job. The 48X complex was schedule driven more than anything else, understanding that budget is always important to a client, but they were highly driven by the schedule. And we were able to maintain the schedule in that project from basically the award all the way through our substantial completion. We actually got about a month and a half early, and they met their first patient deadline with one small caveat that there was a change in design at the conceptual phase where they put a kink in the build. If you go look, it's not a rectangle, there's a bend in it that was part of that. But we reviewed strategies for prefab electrical rooms, mechanical rooms, different types of mechanical systems, above ceiling racks. We looked at doing exterior framing system all the way out to the finishes. We reviewed all kinds of different options. We did utilize a lot of the lean tools with A3s. We did choosing by advantages and went through all of those. And with everything we came up with, it was really just those 4 systems that made sense for our project. Without going into the details, there were some NFPA requirements that made it really difficult to put finishes on the products before we sent the exterior framing out because they weren't tested assemblies. We mentioned it before as far as framing. We didn't do any prefab of full height walls. It was partition walls, but we worked with the architect to go through, STCs and acoustic analysis to figure out where it made sense to have, partition walls that stopped above grid and where that made sense. And overall, along with just the savings in time we had for framing, it allowed our MEP overhead folks to be able to move through the building with ease as they go from room to room, because we pretty much had, king studs at intervals, but beyond that, they could drive their scissors pretty much throughout the building, around the priority walls to do all the overhead rough in. Once they were done, all the partition walls came in and just finished up the walls really quickly. I skipped ahead there. Next slide.
It's okay. Got so excited.
Yeah. Talk about A3s, choosing by advantages. Great tools, especially when you have that collaborative environment and everybody's in the same room going through those different options. Creates opportunities for very, very quick decisions when the decision makers are sitting in the same office as you. Next slide. This is kind of what I talked about before. We went through a multitude of different prefab options, and before we landed on the ones that made sense for the job, and And mostly, I will say, the ones that we landed on, back to the schedule was really the driving factor is they were the different strategies that saved time.
Yes, that was your criteria. A lot, when it came down to criteria, but you weighted it heavier for like.
It was a big part of it, I mean, again, there's a set budget, so everything has to fall within the budget. So I don't think we actually chose anything that didn't save money also. But typically, schedule was kind of the key decision making factor. And frankly, I feel like the schedule and their motivation to get that building done as quick as possible was part of the reason they were so open to the ideas and listening to the approaches that we brought forward. Next one. So implementation, next slide. As Joanne said, as Sully said, as Joe said, as everyone else said, you gotta start early. All of this stuff starts at the beginning of the project. It starts during the concept design, the early specifications, and the overall approach to the drawing. I know there's been a couple comments about framers and how that works with your framing systems. For this project, early on, we went out for proposals and we hired framing out as a design build scope of work. So our framing contractor included their own design, including the structural engineering for the framing system. We had detailers that were in our office that were drawing out the spool panels of everything that we were prefabbing, those details about how you connect the panels, where the king studs go, all of that came from a design build subcontractor. And that, like I said, includes structural design. They sized all the studs, they sized the headers, they did all of that as a design build system. That's really what allowed us to do that prefabricated interior wall system, yes.
With hospitals, then, did they have an SEOR?
They had an SEO, yep. This was an OSHPOD 3 building. That was permitted through UC Davis Health's authority having some jurisdiction.
Gotcha.
But yes, we had SEOR on the job. So those early kickoff meetings that established the groundwork and the operating principles that we were going to do the design based on, and then regular design check-ins that were done in conjunction with the design development for the architect. And so we had pretty much a parallel modeling effort from as early as schematic design that was happening during the course of the design development and the CDs, so that by the time the CDs and the permit documents were done, we were in a position to start our overhead coordination and our detail coordination right after the documents were complete. And I would note on that, I mean, the coordination process is integral to all of this and doesn't go away with that early modeling. Still have to make sure that we have time for the different coordination efforts that have to happen. Next slide. Smart blocking and stacking, claiming space. So again, with these different elements, most notably in this case, probably the prefabricated restrooms. We analyzed each set of restrooms in this job to see which ones were candidates to have prefabricated restrooms, and it wasn't all of them. We ended up with, I think, 24 restroom units on this job. It's less than half. Saved an incredible amount of time, but it's not like a one solution for everything. There was a lot of cases where it just didn't make sense, and we weren't going to try to push something and make it work if it didn't make sense for the criteria or the situation. But then, making sure, again, prefab restrooms is a great concept. It works really well, but you really have to understand the constraints, how to get in, how to get the units in this, where they're supposed to go, how to hook them up, what type of access you need, and those types of things. And that space has to be claimed early on. Mockups, we did, similar to what Joe said, we did a series of mockups both in place as well as virtual mockups, and then we did some actually full-size mockups that were built in a shell space that we put, and then did AR, walks through with the client. And one of the best things that came out of that, I'm sure at least some of you guys have done what we used to call box walks, right? After framing is done, you rough in all the boxes and all that stuff. Everyone goes in, looks, and figures out where we can move them all. Huge waste of time. So just creates rework. But we were able to go through that process through, both in-place mock-ups as well as some AR mock-ups and make sure everybody's happy with head wall layouts and just the IT's always got their own opinions on stuff, and making sure that we're accommodating all of their needs before we actually have work in place. Next slide. And then, as I said before, still a significant coordination effort after all that's done. Once the model is done, there's ongoing coordination. We had ongoing coordination up until every piece was in place. But, and I know, Tom, you're interested in the VDC part of this. I know I do call them kind of high level, but I would say
pictures at least.
yeah, our VDC team was kind of the unsung heroes of this job. You know, both from our staff, the architect, as well as our trade partners on the job.
You feel like they're pretty well meshed, right? Like the best scenario is where the up to the framing people are getting all the heat today, but framing detailers with your architects, like all that, you know, we're having these clusters together, having the design team and the detailers like talk the same language. It's not just like, all right, make that work. I'm done with it.
Yeah.
It's actually like talking through and being right.
Yeah.
On this job, I felt like we had a fully integrated team, you know, more than I've really seen on any other project. So I mean, to the point that our framing detailer was, you know, sat like a row down from our lead architect, literally could turn around and ask questions to the detailer. The detailer was, you know, an old carpenter who'd done this forever, who had amazing computer skills and knew every stud that went into this building. So, and that, you know, and it was great because there's that level of collaboration and coordination. There's no like structure. It's not that your framing contractor turns in an RFI that goes to a project engineer that sits on his desk for 2 days before he turns it in, and then they got 5 days. I mean, it's literally just a conversation that's had, an update to the model. And then, you know, we had our VDC lead who managed that process, and then weekly reviews to make sure that updates weren't happening willy-nilly, but were coordinated and addressed and signed off appropriately.
So you mentioned that you're coordinating up until the time that thing is in place, and I think Joanne said something about this earlier, but how do you guys, maybe an example from Travis, remember how you made updates to the team, like if something changed in the model, say during construction? You guys made that obvious to everybody?
So we regularly publish the model at certain intervals. It was done, and so then we had wall locks and floor locks, and I mean, I say it was done up until we were like putting work in place, but there was a process to lock the model and stop, you know, pencils down. Here's what we're doing, and then address it, you know, through some type of formal change process after that. Even if it's like a field, you know, generated issue.
Gotcha.
Yeah, sorry.
Yeah,
Did that answer your question? I think that was
Fair enough.
Yeah.
Yeah.
Changes happen during
If
the
it's
project.
permit, usually during the, you know, we have the, like you were talking about, we publish them all weekly, so that way everybody can see what's going on. Also, usually we try to get ahead of it, you know, and either during the cluster meeting or during the VDC meeting, we say, hey, this needs to move. You know, it even starts off as simple as like, hey, you know, shooting an email before that meeting, like, hey, I think I've got a problem here. Or somebody comes to you and says, hey, I think we have a problem here. Okay, great, let's talk about it during, you know, like I said, either the cluster meeting or during the VDC meeting, figure out, and everybody kind of agrees to it. And again, the idea is not to have a surprise.
Yeah.
So.
I bring it up because we have this like white paper that we wrote, my company wrote about BIM, and something that I hadn't picked up on it doing a lot of this like integrated projects over 10 years now, is that we expect that there's going to be a discussion about modeling inside of the big room, which I don't think every team does that in detail. And Jacob Lashman and I are on a project, what's up, dog, where somebody in the middle of the meeting would just spot in the big room and they would say, oh, file compare. And we literally have the 2D drawing, the published model you guys are talking about, and there'd be a overlap, and the architect would stand up and go, this wall that was red is now the blue wall down here. We had to move this door or whatever this last week, and then everybody in that big room knew that change made. So there was none of that like, oh shoot, we made this move and nobody knows about it, and we've got to like have to go pull it out again, right? It just was like one of those things where it made it more transparent to all.
Yeah, I mean, we've done our best, but you know, invariably we have had moments like, oh, like for instance, just a couple weeks ago, we had to make an electrical room fire rated that we didn't think we were gonna have to fire rate, and that resulted in, we had a low air return right next, that was going through that wall that we actually now had to put a furred wall on it, so then it became, oh, so somebody didn't So even though we talked about it, we actually talked about it in the MVP cluster, we talked about it in the TI cluster. And then when it came up, but still when it finally showed up in the VDC model, everybody's like, hey, what happened here? And you're like, we talked about this.
I think it's also important to talk about modeling as a tool to provide contract drawings, right? At the end of the day, the contract drawings are the contract drawings. The model is a tool. It's a reference piece. And you should never refer to a model as a contract document. It outputs a contract document, right? So you can track that. I think maybe in the far future that might change, and that's where we're going, right? To get less paper copies, but jurisdictions, authorities having jurisdiction and inspections and all that, and cities are still need that paper copy to inspect too. So it is something that's difficult as the model's continuously changing and trying to keep up with it in the contract documents.
Yeah, and there's still items that we still have to show in 2D, like for instance, our UL assemblies.
Yep.
For
For now.
now.
All right. Yeah, a couple more. And so just to recap kind of where we ended up. So the exterior wall framing, framed and sheeted wall panels that came out to the job site were assembled. We had 383 panels. Overall, it took 9 weeks to install all the framing and sheeting on the building. The interior framing system, Zoe, got the slide? Was done, sorry, wrong slide, sure pods. So the sure pods are restrooms. We had 24 of them that we ended up installing on this project. They were fully complete units, finished with all the fixtures. Actually, I take that back. They were fully finished. The plumbing fixtures we actually had to install on site, but everything else within the restroom, the restroom assembly was complete. And then the last one, interior framing. We had a similar setup that Joe described. We when we took this approach, we rented a warehouse. We set up a fabrication facility. We laid out how we wanted that to go, and we did prefab wall panels with electrical and data rough in only. We did not do plumbing or wet walls, but our prefab assemblies, we did all the partition walls. So anything that wasn't rated or a priority wall or had a significant STC rating was prefabricated in the warehouse, shipped to the job site. Similar with the QR code system, every panel, we had 2,400 interior panels. They were all assigned a number and a QR code. You click on the QR code, it pulls up the spool sheet that shows how it's built, it shows all the electrical dimensioned, and then that lives with it all the way through construction, storage, delivery to the job site. That QR code gets scanned onto the floor with Dusty Robot when they're doing the layout, so you know exactly where to put it, and it has all the details, including labeling which face of the wall is north versus south, east versus west, so that you can't get it backwards. Everything that you would ever need to reference when you click on your QR code from start to finish.
That's a question.
Yeah.
What's the size of your install crew for that 87 panels per day?
I actually don't know that offhand. Great question though.
7.5.
Smaller person
Right?
He wasn't very
Question right here.
For the pods, I saw you guys had like all the interior. Was there anything in concerns of like cracking or like that you maybe like during the movement from the factory to there? Like
We didn't have any cracking or finish issues. Not to say that the system was flawless. There were some issues that we had to deal with as far as some fit up things, but nothing with like cracked tile or walls or anything like that. Honestly, I think the biggest issue we had was coordinating accessories in the photos in the restroom. So
Most expensive too.
yeah.
They're outrageous.
With your pods, like, the thing that always boggles my mind is how do you make the final connection? So say like a bathroom, you've got, obviously waste lines and risers and stuff, you've done lines.
Yeah, it all comes out on the top. We actually we had an option of buying the pods with basically a rated top that's structurally rated so somebody can work on the top. So we did that. And so there's connection points in the back as well as the top, and then of course drains in the floor.
How do you make that connection? Is that sucker floating or do you have a depression or how do you make the final?
There's a
connection?
depression in the floor, right? Because it's got a finished floor that's like 1.5 inches. So we had floor depressions, and you set it in, you anchor it down, you grab around to fit it all in so everything's flush. And then you gotta make your plumbing connections.
And then how much do each of those pots weigh?
I don't know how much they weigh, but I mean, we had a crane on site. We had landing things and never had an issue.
Very
moving them. Yeah, and so.
Typical patient restroom with tile weighs somewhere around 3,800 pounds.
I'm just wondering, like, you're pallet jacking into place or do you?
You can, I mean, you can use roller systems, you can use pallet jacks, it's just rig it.
Yeah, we didn't have to have any type of specialized hoisting at all. You know, there's no structural concerns with rolling across the floor or anything like that. So, I mean, obviously you do have to coordinate to get them in time before the walls are framed and so you have access. But, I mean, it was just a coordination timing with all of this. Yes?
I had a question really for the whole panel about VDC. How do you ensure that the actual component, or what are the ways you can ensure that the actual component is placed where the model says it's supposed to be placed? Who are the key people that have the VDC coordination meetings for that, or what kind of controls or checks are most successful to ensure that happens?
So that's like the handoff from the VDC to the school sheet? Is that where you're kind of?
Well, just if you've got.
Field coordination with.
For instance,
Yeah.
we struggle, we model it, it's coordinated, it looks great, happy, and we go, okay, and then you get a foreman out there who goes, nope, I want to do it this way, and he starts throwing up stuff that is not for the model. It's current contract documents, but it's not for the model. What kind of strategies are there that help with that?
You limit the information that they have and you make it as simple as possible. That's really, and you use tools, like you said, the total station, Dusty, anything that you can to take the model elements and make sure that it's laid out accurately in the field. And then on the drawings that we give the field, they are as tore down as possible. So they're only looking at what they need to put in. They're not looking at all the other data that's on a contract.
Okay, so simplify their instructions.
As
Yeah.
much as possible.
I would note, so on this job, and sorry, a little contrary to what you were saying, we were building the model. We had QC teams that were going through the model. We had a group specifically going through and doing just spot like checks in each room where they do elevations and check all of the data and outlet and utilities, check it against the medical equipment plan to make sure everything was there, and really validating the accuracy of the model. And then our construction people build off the model. So, and but it's that QC process ahead of time to make sure that model meets the construction drawings. And but the model's the tool that the field team really relies on.
So, and I've even found that seeing the foreman starting where they might not necessarily be in the VDC meetings, because that's not necessarily what they're interested in, but they're in the cluster meetings. So they're hearing the conversations that are going on from like day one. And so the foremen aren't necessarily actually get to hear what the discussions are. And it does sort of keep them from going, no, I want to do this, to just for them to even understand that we have talked about it and that there's some thought going behind it.
So would you say they have a little more ownership of it or whatnot, or buy-in, I guess?
I think that there's a lot more buy-in, yeah.
And that's the trick too, is you're taking work from the field team but you still want them to have ownership in the product. They're the ones that are putting the work in. So it's a culture shift as well. I mean, MR3 have been doing this for over a decade now. We're still, I wouldn't say fighting, but you still run into, especially when you bring on new people, new foremen, new field personnel, it's getting that culture shift for them to understand that, hey, you still need to understand your contract line. You still need to know your job, but you also need to understand the work that's gone into what we're giving you and understand that if something does change, you don't just change it on the fly. You need to communicate what the issue is, whether it's using tools like Procore for observation logs, whatever that is. You need to make sure that's a culture change as well.
And that's part of the whole APD and everything else, is really setting those expectations up front, involving them in the constructability review so that they do understand what's going in and that they're buying off on, yeah, I can install what you're designing, I can install what you're prefabbing and what you're manufacturing, and then you don't really run into those issues.
And I think that's an important point, getting back to building off the model. I think we do build off the model. What I'm saying is that there's a conflict between the model and the contract documents. The documents are gonna take precedence. So being able to use that as a tool to produce the contract documents is the benefit in the prefab.
That's a good way to say it.
So one thing I want to add on Joe's project, the client actually had us use a product, I'm not going to say what the product was, but it utilized laser scans to compare the model versus what was built. One of the interesting things, something you're kind of alluding to, we had one of our trade partners, after we did our model sign off, and they're not supposed to change it, took it upon themselves to optimize their system and change it. But we caught it real early on because we started to see that what they're building did not match the model. The foreman had his shop drawing, so I'm building off of this, or looking at it, it's like, that doesn't match the model. Why is it? It was because they did that, and then they had to go back and do a lot of rework. But we were able to find that really early on, so we were able to correct it. And once they saw that we were paying attention, they got on board and we're doing what they're supposed to. So it does happen. I mean, we hope that it doesn't, but we got to be on top of it.
You guys, are we wrapping up? Can I ask?
I think we're really close.
I have a wrapping question I'm gonna ask, so I'll save it.
You gotta wrap it.
Yeah, you need a beatbox?
Yeah.
We are, we're IT ignorant, so we're right here.
This is such high level stuff. I mean, I know you guys all realize this is very high level and can't just use the word IPD. My biggest concern is how I can scale this for the majority of the work that we do. And I'm thinking about a 10,000 square foot tenant improvement, a repeatable job, a healthcare repeatable job. We're doing a ton of that, right? Like our work is ambulatory, and scale is more ambulatory than everything.
Yeah.
The bigger jobs, few and far between, and they're all going to go halfway with my company. But for everybody in the room, like, how do we scale this type of stuff? Like, what are the
Repeatable design.
baby steps?
You're gonna have a high expenditure in the first couple of them. I mean, all bullshit aside, it's going to happen because you're expending the time to create those models and create the templates and those things. And so you have to have an owner that's bought in that, yeah, we may not make money on the, save money on the first two, but then it's gonna accelerate and that volumetric efficiency is gonna get higher and higher. And you're really looking at the 10-year programmatic approach that the next 10 of them we build after that, it's gonna incrementally save more.
Ken, do you think that a component is that the same team doing that?
I don't think it necessarily has to be the same team. It's the same design. Like if you create the chassis that if you create that standard chassis, because everybody wants to have customization. And so, where you put in wall accessories, where you do finishes, again, changing that. But if you create a chassis that can be parametrically adjusted and you stick to that repetitively, I mean, there's companies like HCA that do that all the time, and then there's others that give clinicians a lot of room to make adjustments and it's almost impossible. But if you have a customer that's willing to, and budget is important as schedule, and they make that commitment, it can occur in the smaller projects.
I will admit that we are making strides in that way. We've got a long ways to go.
Yeah.
But one of the key parts of that is like we lease crazy buildings all over. We just lease a space that is in the right place for the right amount.
Yeah.
We really can't. We have to make some concessions about like our clinic module and things like that to make it fit.
Yeah.
So that's where we get in a pinch there.
Yeah,
right?
if you can stay at 70% in repeatable, you do pretty well.
Yeah.
And then the rest being infill and.
So like exam rooms, treatment rooms.
Pick 5 or 6 templates that these are the same in every building. Spatially, those are arranged and fit, and then, create that system that allows you to, and then infill panels and infill rooms and you can even do them in wall panels. You can do them in kits of parts. There's a lot of steps to it that still create that efficiency and can create a product catalog for that particular customer that they can draw from.
You still think it's efficient to do full coordination modeling and tenant improvement?
I think if you get to where you're doing templates, it's really like, if you're setting a rooftop unit or anything else, it's got a predefined parameters in that design. And if you can create those templates, then you're not spending the VDC time. It's like, this is model 4833, and I want 12 of those. And so that's really where it gets to, is making that investment in those templates, because you're not redesigning it. You're just putting placeholders and then you're ordering product numbers.
All right, any other questions? I'm sorry if you were expecting more about VDC. I know that came up several times. VDC is critical to making this actually work, like being able to coordinate to a high level to ensure that what is prefabricated actually can go in and match up with everything that's stick built. We will have a future part 3 to this where we're going to talk about LOD. So, watch for that. It'll be later in the year. All right. So let's do a quick plus delta. If you want to pull out your phone, all you got to do is scan the QR code.
We're done. I appreciate all of you. Thank you.
Thank you very much.
Thank you, guys. That was awesome. Thank you.
Hopefully everybody found something to take away. And this was